Let us discuss the color code for resistors, generally कार्बन resistors के लिए. इसके लिए there is an acronym that BB Roy. It's a name we have taken, BB Roy. In Great Britain, from Great Britain we have taken GB, had very good wife. All those capital letters have been taken here. BB Roy in Great Britain had very good wife. If you count the number of letters here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And in this sequence, if you now write in vertical manner, then they will be written as BB Roy in Great Britain had very good wife. Number starting from 0, 1, 2, 3 have been allocated for them. 0 to 9 letters have been allocated for them. Now, what is the meaning of this B? This B means black. This B means brown. This R means red. Red color strip. O means orange. Y is yellow. This G is green. This B is blue. This V is violet. This G is grey. And W is white. These are the possible colors you can see on a carbon resistor. These are the colors. ये सारे colors के strips हो सकती हैं. In addition to that, the fourth strip, generally you will find 3 strips are belonging to these colors. And उसमें एक fourth strip भी हो सकता है. For fourth strip, we have the convention that in case the color is gold, then that is indicating the tolerance of the resistor. Tolerance means the variation, because resistance की value constant नहीं रहती है. With the change in temperature, the value can change. The change of plus minus 5% has been indicated by gold color. In case the color is silver, then variation 10% तक की हो सकती है. And in case there is no color used, that means the resistance value can vary between plus minus 20%. Now, what is the meaning of this color code? Imagine that you got a carbon resistor. I am showing a very enlarged view of that. Generally carbon resistor देखने में ऐसा होगा, cylindrical. You will find there some colored strips are there. As I said, पहले 3 strips होंगी and fourth strip optional है. Fourth strip हो भी सकती है. Assume a situation in which the first color is red, second color is yellow, third color is orange, and fourth color which you have, that is silver. First strip is red, second is yellow, third is orange, and fourth strip is silver. Now, what is the value of this resistance? Then you see what is the number for red. Red का जो number है वो क्या है? 2. So you write here 2. Then you see what is the number for yellow. Yellow का number है 4. You write 4. Into 10 to the power you will be putting from your side. अब आप खुद से ये into 10 to the power लगाएंगे. And the value of power will be decided by this third color. For example, here orange has number 3. So this power will be 3, indicated by this orange. And then plus minus Silver stands for 10% tolerance, plus minus 10%. ये इसकी वैल्यू होगी. This is the value of the resistance you have here. You understand? So this is the way color code for resistors have been decided. International convention is this, so you also have to follow that. A numerical question generally will be asked that will be based on this kind of notations. Now let us verify Ohm's law with the help of some basic equations. Now let us verify Ohm's law. For this purpose, remember that inside a conductor you have applied a voltage. The voltage I am indicating by capital V. Let us suppose the length of the conductor is L. Cross-sectional area here which you have, that is A, because of which inside this conductor an electric field E has been set up. You can successfully write that electric field E will be potential upon length. This you have already seen in the chapter of electrostatics, that potential difference upon total length, that will be the electric field. Now because of this electric field, what happens that these electrons are on an average motion. You can say an acceleration is there on the electrons. Acceleration आप लिख सकते हैं force upon mass होगा, and force is what? Charge into electric field. What is the charge on electrons? E. So I have written here acceleration is equal to force upon mass, that is electronic charge multiplied by electric field upon mass. And you can understand it that between two successive collisions, they are electrons random motion, they are in constant collision process. Between two successive collisions, the average speed is V. You are, let us suppose, using the formula V is equal to U plus AT. I am using this formula for average speeds. Average speed you will be writing as drift speed. Initial speed is 0 because जैसे ही collision हो गया, collision के बाद electron is starting with 0 speed, and the average speed it acquires, that is Vd, is equal to A into tau. This tau is a new term which is coming to you. Tau is called relaxation time. Tau is called relaxation time. This is essentially, you can say, the mean time an electron spends between two successive collisions. जब उनकी random collision चल रही है तो दो collisions के बीच में जो वो average time spend करता है, that time is being called relaxation time. Now you see, you have from the beginning a basic formula that I is equal to NE VDA, isn't it? This is the basic formula you have. Now I will substitute for this VD. VD will be, as you have just now written, this is acceleration into relaxation time. So this is A into tau multiplied by capital A. And now for this acceleration A, I will write EE by M. Just now you have written here acceleration is EE by M. So I have written there. And this relaxation time tau. And then this cross-sectional area A. You understand? And for this electric field, now I will substitute, this is V upon L. So this will be I is equal to NE E V upon L. Now if you simplify it, then you get I is equal to N E square, all those constant quantities I am writing together, N E square tau A upon ml and multiplied by capital V. You understand? This manipulation finally gives you that current is equal to some constant quantity. All these quantities which you see in the bracket, वो सारी constant हैं, and at the end you have V. So you can say that I is proportional to V as obtained by our basic equation, and ये पता है आपको कि that was Ohm's law. So we have essentially verified this Ohm's law. Now whatever quantities you see in the bracket, what do you think what it is? ये जो पूरी quantities bracket में लिखी गई है वो क्या है? That is just 1 by resistance, isn't it? Because I is equal to V by R. So from here you have very important thing to learn is that you have a very important thing to learn is that resistance is equal to ML upon N E square tau A. And you have also studied that resistance is equal to rho L upon A. So now if I equate this quantity to this quantity, you will find that this L cancels this L, this A cancels this A, and finally a very important formula you get, that resistivity, which is a material property, is dependent on mass of electron, number of electrons per unit volume, electronic charge, and relaxation time. Sometimes this formula will be directly asked to you in the question to recognize, and when we say that temperature is increasing, then resistivity is increasing, so that is also explained by this formula, that we say when temperature is increasing, the random motion is increasing. Now when the random motion will increase, the time interval between two successive collisions will decrease. जब collisions जल्दी जल्दी होंगे तो दो collision के बीच में time कम हो जाएगा. That means the relaxation time will become less, and when the relaxation time will become less, automatically resistivity will increase. That is why we say that when temperature increases, जब temperature increase करता है, then relaxation time decreases, and because of which resistivity increases. Now at the end, let us discuss dependence of drift speed on certain factors. Let us now have a discussion on drift speed at the end. This discussion is related to the conceptual questions which are asked. Imagine a situation in which a conductor is given, the length of the conductor is L1, the voltage which you have applied here is V1, and the cross-sectional area of the conductor you have here is A1. आपको दिया गया है कि एक कंडक्टर है, उसकी लेंथ L1 है, एरिया A1 है, वोल्टेज V1 है. Now suddenly the conductor has been changed. Now let us suppose उसकी length, the length has become L2, cross sectional area is also changed, A2, and voltage may be changed. Question is that how drift speed is related to, अगर आपने वोल्टेज चेंज किया है, एरिया चेंज किया और लेंथ चेंज किया है, हाउ ड्रिफ्ट स्पीड इज चेंजिंग, हाउ Vd इज रिलेटेड टू वोल्टेज चेंज, लेंथ चेंज और क्रॉस सेक्शनल एरिया चेंज. Then you see your starting point should be a basic equation. The basic equation we have is I is equal to NEVDA, and you can see here in this question the current is not appearing, rather voltage and resistance, those things are appearing. So we are successfully replacing this I as V by R. V is voltage, R is resistance, is equal to NEVDA. And as you had seen that resistance is equal to, this resistance is equal to rho L upon A, then now this can be equated to the right side of the equation, that is NEVDA, or you can say VL, V into area upon rho L, this is equal to NEVDA. Now if you manipulate this, you will find that area is not appearing, and Vd can be written as, from this place Vd can be written as V upon rho L Ne, V upon rho L Ne. What is the meaning of this? इसका मतलब यह है कि ड्रिफ्ट स्पीड इज डायरेक्टली प्रोपोर्शनल टू वोल्टेज. अगर आपने वोल्टेज इंक्रीज किया है तो ड्रिफ्ट स्पीड भी इंक्रीज कर जाएगी. इन केस you have increased the length you can see it is in denominator. अगर आपने लेंथ इंक्रीज किया है तो ड्रिफ्ट स्पीड डिक्रीज करेंगी, बट एरिया, क्रॉस सेक्शनल एरिया चेंज इज नॉट appearing here. So the change in cross sectional area will not make any difference in drift speed. So conclusion is that drift speed is directly proportional to voltage change. है ना, जब वोल्टेज इंक्रीज करेगा तो ड्रिफ्ट स्पीड अकॉर्डिंगली इंक्रीज करेगी. ड्रिफ्ट स्पीड इज इनवर्सली प्रोपोर्शनल टू लेंथ चेंज. लेंथ अगर इंक्रीज करेगी तो ड्रिफ्ट स्पीड डिक्रीज करेगा. एंड Vd इज independent of this is a very important matter. Vd is independent of change in cross sectional area. You understand? But at this point, I would like to bring one very important point in your mind. कई बार हमने देखा है कुछ क्वेश्चंस में आप गलतियां करते हैं. You are making a mistake if you are blindly following this. Remember that in this question, there is a comparison of two conductors. हमने आपको क्वेश्चन में ही दो डिफरेंट कंडक्टर्स दिए हैं, एंड दो डिफरेंट कंडक्टर्स में कंपैरिजन की बात थी. The area was here something else, area was there something else. Let us suppose आपको एक क्वेश्चन इस तरह का देते हैं हम. I am trying to make you careful. You have been given a question like this. Here you see a conductor is there whose cross sectional area is gradually increasing, and it has been connected to a voltage source. and at this point they are saying that the drift speed is v1 and at this point the drift speed is v2. This v1 v2 they are drift speed and आपसे पूछा गया है कि whether these drift speeds are same or they are different. तो at times आपके दिमाग में ये चीज घूमती है that drift speed is independent of change in area and आप लिख देते हैं that v1 is equal to v2, but mind you v1 is equal to v2 ये करेक्ट आंसर इस पर्टिकुलर क्वेश्चन के लिए नहीं होगा. Why? Because maybe these questions are looking alike. ये देखने में हो सकता है दोनों क्वेश्चन एक जैसे लग रहे हो, दोनों क्वेश्चन एक जैसे हैं नहीं. Here the matter was to compare the quantities, compare the drift speed in two different conductors. But here you have to compare the drift speed on the same conductor but at two different points. You understand? यहां पे आपको ड्रिफ्ट स्पीड दो डिफरेंट कंडक्टर में कंपेयर करने की बात चल रही थी, बट यहां पे सेम कंडक्टर के दो डिफरेंट पोजीशन पे कंपेयर करने की बात चल रही है. एंड वेन एवर कंपेरिजन थिंग्स आर देयर, रिमेंबर दैट यू शुड राइट द बेसिक इक्वेशन एंड यू शुड ट्राई टू सी व्हाट आर दोज थिंग्स विच आर कांस्टेंट. अगर आप इस क्वेश्चन को सॉल्व करेंगे तो आपका बेसिक इक्वेशन ये है. नाउ टेल मी इन दिस क्वेश्चन व्हाट इज दैट क्वांटिटी विच इज रिमेनिंग कांस्टेंट. तो इस क्वेश्चन में आप कहेंगे कि जितना करंट यहां से एंटर करेगा, वट एवर अमाउंट ऑफ करंट विल बी एंटरिंग हियर, उतना ही करंट यहां से बाहर निकलेगा. सेम अमाउंट ऑफ करंट विल बी कमिंग आउट. यू एग्री? तो यहां पे इस क्वेश्चन में रिमेंबर दैट दिस क्वांटिटी इज कांस्टेंट. This quantity is constant and accordingly rest of the things will adjust themselves as per this condition. यहां पे करंट कांस्टेंट है और बाकी सारी चीजें इसके हिसाब से अपने को एडजस्ट करेंगी. मतलब दैट मीन्स इफ यू आर मूविंग फ्रॉम लेफ्ट टू राइट, देन इफ एरिया इज इंक्रीजिंग देन ड्रिफ्ट स्पीड विल बी डिक्रीजिंग. यहां पे जैसे जैसे एरिया बढ़ेगा ड्रिफ्ट स्पीड की वैल्यू डाउन होती जाएगी. वजह यह है कि जो करंट है, द करंट इज कांस्टेंट, सो इफ द एरिया इज इंक्रीजिंग द ड्रिफ्ट स्पीड विल बी लेस. तो इसका आंसर अगर आप सोचेंगे तो रिमेंबर दैट दिस ड्रिफ्ट स्पीड इज लेस एंड दिस ड्रिफ्ट स्पीड इज मोर. दिस इज अ इंपॉर्टेंट पॉइंट. यू अंडरस्टैंड? ये जो आपने स्टेटमेंट लिखा है इससे कोई ज्यादा कंक्लूजन ड्रॉ करने की जरूरत नहीं है. ये कब वैलिड है? ये तब वैलिड है जब दो डिफरेंट कंडक्टर के कंपैरिजन की बात है. बट अगर एक ही कंडक्टर के दो जगह के कंपैरिजन की बात होगी तो आप इस बेसिक इक्वेशन से ही स्टार्ट करेंगे और एरिया इंक्रीज करेगा तो ड्रिफ्ट स्पीड डिक्रीज करेगी. सो दिस इज द मेन कॉशन यू हैव टू टेक व्हाइल यू आर डीलिंग विद ड्रिफ्ट स्पीड. सो बिफोर वी गो अहेड, लेट अस समराइज व्हाट ऑल वी डिस्कस इन दिस लेक्चर. In this lecture, first we talked about what is the meaning of electric current. इसमें हमने ये देखा कि what is the meaning of average current, instantaneous current. Average current क्या है? Instantaneous current. What is conventional current? What is electronic current? Then we essentially talked about drift speed. हमने drift speed के बारे में एक इंपॉर्टेंट फॉर्मूला डिराइव किया. इसमें I is equal to NEVDA. यहां पे इलेक्ट्रिक करंट I was Q by T or delta Q by delta T as the case may be. These were the two basic equations. Then we talked about Ohm's law. Ohm's law, essentially we said that it is I proportional to V. ये Ohm's law था. Then we talked about geometrical dependence of resistor. Then we talked about temperature dependence of resistor or resistivity. For geometrical dependence, we said that R is equal to rho L by A. For temperature dependence, we said that resistance is R naught 1 plus alpha T. We also wrote a special case that if temperature change is small, then you can write this equation like this. Same thing you wrote for resistivity as well. Then you talked about color code of resistors. Then we verified Ohm's law. And at the end, we had discussion on drift speed, in which I made you careful that how can you make mistakes. So this is all in today's lecture. In the next lecture, we will be talking about the networks, the Kirchhoff's law and RC circuits. Thank you.